Hello everyone and welcome to the part 2 of AWS Compute Services Selection Decision Guide. So this lecture will contain only these two topics: ideal use cases and workloads, scenarios where it is less suitable and key differentiator from similar services. Second, key concepts for certification exams, common exam confusion points and important service limitations to remember. So first, ideal use cases, workloads, scenarios where it is less suitable and key differentiators. So first we have Amazon EC2. So ideal use cases are general purpose compute, legacy apps where you need full control, and stateful apps. It is less suitable for simple web hosting. For that, Lightsail is more appropriate. Event driven code, for that Lambda is more appropriate, and managed containers. So key differentiators are granular control versus Lightsail's bundle simplicity, infrastructure management versus platform as a service and function as a service abstraction. Next, Amazon EC2 Spot instances. So ideal use cases and workloads are batch processing, high performance computing, CI/CD, fault tolerant stateless applications, and cost optimization. Less suitable for critical, stateful, and interruption sensitive workloads. Key differentiators: deeper discounts with interruption risk, market pricing versus committed discounts. So we have savings plans for that, and on demand, which is the default. Next, Amazon EC2 auto scaling. Ideal use cases and workloads are applications with variable load, high availability needs, cost optimization via scaling. It is less suitable for static load apps, workloads where instance identity and longevity is critical. Key differentiators are manages EC2 Spot dynamically based on the policies, unlike manual scaling. Next, AWS batch. Ideal use cases are large scale batch processing, for example genomics, finance, rendering, and asynchronous tasks. Less suitable for interactive or real-time applications. Key differentiators are managed batch orchestration versus manual job scheduling on EC2 containers. It abstracts compute environment management. Next, AWS Elastic Beanstalk. Ideal use cases are rapid web app deployment, platform as a service experience, developers unfamiliar with the infrastructure. It is less suitable for non-web apps needing deep infrastructure control and complex container orchestration. Key differentiators are higher abstraction and automation for web application versus EC2, simpler than Elastic Container Service and Elastic Kubernetes services, but less flexible. Next, services, Amazon ECS. Ideal use cases are microservices, containerized web apps, batch jobs, tasks, and AWS native orchestration. It is less suitable for if you need full Kubernetes control or API ecosystem. For that, EKS is more suitable. Multi-cloud portability needs. Key differentiators are AWS proprietary orchestration versus EKS, which is Kubernetes standard. Simpler control plane and API versus EKS. Next, service, Amazon ECS Anywhere. Ideal use cases are hybrid container deployments, extending ECS to on-prem, and compliance needs. It is less suitable for no on-prem infrastructure if you need Kubernetes, EKS Anywhere, and fully cloud native apps. Key differentiators are it runs ECS tasks on customer infrastructure versus ECS in AWS. It requires customer infrastructure management versus AWS managed ECS. So this is just the slight difference between ECS and ECS Anywhere. And there is a slight contrast with Kubernetes, which is EKS Anywhere. So EKS Anywhere, you run EKS on-prem plus hybrid solution on AWS, but this is ECS and is slightly different from ECS. So next, Amazon ECR. Ideal use cases are storing private public container images for ECS. So ECS will just pull the images from here. So Elastic Container Service, EKS, Lambda, code build. So all these services can pull the images from the container registry. And less suitable for, this is a registry service and this is not compute. So you just store the images, container images. Key differentiators are it's a managed AWS registry versus Docker Hub or self-hosted. Integrated scanning, and you have lifecycle policies. Next, we have Amazon EKS. Ideal use cases are Kubernetes workloads, multi-cloud hybrid Kubernetes strategy, unique Kubernetes ecosystem and API. It is less suitable for Kubernetes complexity undesired. So if you do not desire that kind of complexity, it's less suitable. Prioritizing AWS integration, so ECS is better, and simpler needs. So if your needs are simple, ECS will do the job. Key differentiators: managed Kubernetes standard versus ECS, which is AWS proprietary. It is more complex but portable and extensible than ECS. Next, Amazon EKS Anywhere. Ideal use cases are running Kubernetes on-prem with AWS tooling consistency, and you have data sovereignty for Kubernetes application. It is less suitable for no on-prem infra, Kubernetes requirement, and preferring fully managed Kubernetes. So for that, you will go for EKS. Key differentiators: it runs Kubernetes on customer infra versus EKS, which runs in AWS. Customer manages lifecycle versus AWS managed EKS control plane. Next, services AWS Fargate. Ideal use cases are serverless containers, and that runs on ECS and EKS, microservices, APIs, batch jobs without server management. It is less suitable for if you need operating system level control, specific instance types, GPU, long execution. Key differentiators are it runs containers versus Lambda, which are functions, no execution time limit versus Lambda, which has an execution time limit, serverless versus EC2, and ECS on EC2. AWS Lambda. Ideal use cases are event-driven processing, serverless APIs via API gateway, real-time data processing, and automation. It is less suitable for long-running compute. So there is a limit of 15 minutes. So if your compute or any transaction runs more than 15 minutes, you cannot go for it. There's a hard limit. Stateful applications, which have local persistence, so it's not suitable for that kind of stateful application. And it is not suitable for containers because they are long running, or sometimes most of the time they will cross 15-minute threshold limit. Key differentiators are function based versus Fargate, which are container based. Event triggered versus Fargate, which is continuous. Time limits versus Fargate. There is a limit and Fargate has no limit. AWS local zones. Ideal use cases are low latency applications for metro users, hybrid migrations, data residency, gaming and media. It is less suitable for no metro presence required, requiring services unavailable, and ultra low mobile latency. Key differentiators are AWS managed regional extension versus Outpost, which is customer site hardware, versus Wavelength, which is specific to 5G edge and 5G network, telecommunication, telco 5G edges. Next, AWS dedicated local zones. So ideal use cases are exclusive AWS infrastructure, strict data sovereignty, compliance, and for regulated industries. It is less suitable for general use cases, shared local zone sufficient, and no strict exclusivity. Key differentiators: exclusive and customizable versus shared local zone, which was a previous service. Managed by AWS versus customer managed Outpost. So Outpost I will also come. AWS Outpost. This is ideal use cases are on-premises compute storage needs. So AWS consistency when you need and similar user experience, then you will go for this. Ultra low latency, local data processing. It is less suitable for no on-premises requirement if local zone meets latency needs and cost sensitivity. So this will be higher cost, so you will go for local zone. So local zone meets latency needs, and if it is cost sensitive, you will not go for this. So it's less suitable. So key differentiators are: this is a customer site AWS hardware versus AWS site local zone versus telecommunication site wavelength. So there are 4 services which are very close to each other. And managed hardware versus anywhere, which is EKS which is our local zones. Next, AWS wavelength. So ideal use cases and workloads are ultra low latency mobile applications for 5G, augmented reality, virtual reality, connected vehicles, and mobile gaming. It is less suitable for non-mobile apps, telco edge not required, and local zones efficient for latency. Key differentiators: telco 5G edge versus metro edge, so local zones, versus on-prem, which is outpost. Focus on mobile ultra low latency. Next is the savings plans. So ideal use cases are steady state compute usage, for example EC2, Fargate, and Lambda. They are part of savings plans, and long-term savings commitment. It is less suitable for highly variable, unpredictable usage, short-term needs, and needing capacity reservation, which is for reserved instances. Key differentiators are commitment-based discount versus spot, which offers market discount plus risk. Second, more flexible than reserved instances. There is no capacity reservation. Next one is AWS Compute Optimizer. So ideal use cases and workloads are optimizing cost, performance of existing EC2 auto-scaling groups, Elastic Block Store, Lambda, ECS Fargate, and Relational Database Service RDS. It is less suitable for recommendations not actionable. So it will give recommendation, but you cannot directly act. So you have to manually take action. And unsupported resources, so all are not supported, all these are supported. And if you need real-time optimization, because it will provide recommendations. Key differentiators: it provides recommendations versus auto-scaling where you have to take action. It analyzes usage versus manual analysis. Next, EC2 Image Builder. Ideal use cases are automating golden image creation, patching, testing, and that includes both AMI, Amazon Machine Images, and containers, and it follows all the standards. Less suitable for one-off image creation, migrating existing images, complex non-standard builds. Key differentiators are it automates image lifecycle versus manual image creation and management. Next service, Elastic Load Balancing, ELB. Ideal use cases are distributing traffic for high availability and scalability. It includes web apps, APIs, and network appliances, gateway load balancer. Less suitable for single instance applications where no HA or scalability are needed. Key differentiators are manages traffic distribution versus compute services, and it supports different types, which includes application load balancer, network load balancer, gateway load balancer for different layers and protocols. And lastly, Amazon Lightsail. Ideal use cases are simple web apps, blogs, dev test environments, users who are new to AWS, and there is a predictable low cost. It is less suitable for complex apps which needs granular control, high scalability, full AWS service integration. Key differentiators: bundled simplicity and predictable pricing versus EC2's granular control and pay per resource model. And this is the last part. We'll go through key concepts for certification exam, common exam confusion points, and important service limitations to remember. So first one, Amazon EC2. Key concepts are: we have instance types, families, and sizes. We have AMIs, which will provide the images. EBS, block store, which provides the storage, versus instance store, which will run and terminate when the EC2 is stopped. This is long-term, persistent, stateful. Then we have security groups and pricing. Common exam confusion points are specific instance types nuances that we have to know, whether it's burstable or GPU based, EBS types, performance, reserved instances versus savings plans versus spot. Important service limitations. So there are some account limits, for vCPU and instances, how many you can spin up, resource limits per instance type. Next is EC2 spot instances. Some key concepts for the exams are interruption handling, like there is a notice, stop, terminate, and hibernate, bidding, and use cases. Common exam confusion points are, so there is there's spot versus savings plans and reserved instances where you have a commitment and there is no interruption, and this one have an interruption, it can be interrupted. And to know the interruption behavior, and max price versus market price. Important service limitations are availability cannot be guaranteed. There is a 2-minute warning that and in that 2 minutes you have to engineer so that if you are running some stateful, make sure that you persist in S3 or some kind of storage, and it is best only for fault tolerant workloads. So it doesn't matter whether, let's say you are running some analytics, you can run whenever there is no like urgency. Whenever you get time, you can run. If it dies, it doesn't matter. You can rerun it again. Next, EC2 auto scaling. Key concepts for certification exams are launch templates and launch configs, scaling policy types, auto scaling group components, and health checks. Common exam confusion points are scaling policy types, use cases, launch templates versus launch configs. So launch template was the older standard or mechanism. Then they introduced launch configs. Then elastic load balancing health check, integration, and termination policies. Some important service limitations are cooldown periods, scaling speed relative to instance boot time. Next, we have AWS batch. Key concepts for the certification exams are job definition, job queues, compute environments which are managed, unmanaged, EC2 based, or the Fargate. Common exam confusion points are job states lifecycle management, its relationship to ECS, and Fargate, which can be underlying compute. Important service limitations are primarily for batch, it is non-interactive, and there are some service quotas which apply. Elastic beanstalk. Key concepts for certification exams are we have applications, we have environments, platforms, deployment policies, and .eb extensions. Common exam confusion points are beanstalk versus CloudFormation, which is like a infrastructure as a code service, and OpsWorks, which is like configuration as a code, and managed platform updates versus manual control. Important service limitations are customization constraints, platform support lifecycle, and any kind of deprecation. Amazon ECS. So key concepts for certification exams are task definitions, services, clusters, launch types, EC2 and Fargate, and networking modes. Common exam confusion points are ECS versus EKS, simplicity versus Kubernetes standard, EC2 versus Fargate implications, control versus serverless. Important service limitations. So there are some service quotas, networking limits per EN9, Elastic Network Interface, and this is AWS proprietary, this service. ECS Anywhere. Key concepts for certification exams, hybrid use cases, external instance registration via agents, and we need an IAM role. Common exam confusion points are ECS versus ECS Anywhere management, the responsibility, network, and load balancing limitations on-prem. Important service limitations. So no native ELB service and service discovery for external instances. It requires customers' infrastructure. Next, Amazon ECR. So key concepts are repositories which can be public and private, tagging, lifecycle policies, and image scanning. Common exam confusion points are ECR versus Docker Hub and other registries, repository policies versus IAM policies. Important service limitations are storage, transfer cost, and there are throughput quotas are applicable. Amazon EKS, Kubernetes. So key concepts for the exam are it's a managed Kubernetes control plane, node groups, Fargate profiles, and IAM integration. Common exam confusion points are EKS versus ECS, Kubernetes versus AWS proprietary, EKS versus self-managed Kubernetes which can be on-prem, and IAM integration. Important service limitations. So again, it's the Kubernetes complexity, control plane cost, which is $1 per hour, and node pod limits. EKS anywhere. Key concepts for the exam are on-prem Kubernetes use case. There is a EKS distro involved because you will use EKS distro to spin up EKS anywhere cluster API providers, and EKS connector. Common exam confusion points are EKS versus EKS anywhere, the previous service which is managed, and this is self-managed, but you get the same user experience but on-prem. Networking and load balancing options like through Metal LB and F5. Important service limitations are it requires customer managed infra, AWS support optional, and there are some optional, and you can go for paid support also, and there are limited packages which come via EKS distro. Next, AWS Fargate. Key concepts are these are serverless containers, and this is for ECS and EKS. Task pod definition, CPU and memory configuration, and use cases. Common exam confusion points are Fargate versus Lambda. One is container, one is function. Second, time duration. Fargate with ECS versus EKS. Important service limitations, no direct operating system access. Concurrent task limits, so there are some quotas, and max vCPU and memory per task. Next, AWS Lambda. Key concepts are event sources, triggers, runtimes, memory and timeout, Lambda layers, concurrency, role, and VPC. Common exam confusion points, Lambda versus Fargate. Again, same function versus container. Core starts impact and state management. Important service limitations, 15-minute timeout, memory limit which is 10 GB, time 15 minute. There are some concurrent quotas and payload size limits are there. Next, AWS local zones. So key concepts are region extension use case, low latency benefits, VPC subnet extension. So basically, this service will offer in certain regions and certain zones, you can extend, and that will be very near to your on-prem. Common exam confusion points are local zones versus wavelength, which is 5G, versus outpost, which is directly on your location, and management latency. So this is near your data center, but still owned by AWS. So they have worked with data centers or data center providers, and they have set up their own infrastructure very near. So if you happen to be near them, you can go for local zone, which will be like very super low latency compared to directly working on the cloud, but this will cost some extra. Important service limitation. So this is limited service availability because they cannot work with every all around the globe, and they cannot have their own infrastructure in every data center's provider's location, right? And network routing limitations, and there are no VPC endpoints which are available. Dedicated local zones. So this is very exclusivity. So you have to work with them. If you have data sovereignty needs, that data can never go out, then you can ask, but you have to work with them. You have compliance use cases, and you need some customization. Common exam confusion points are dedicated versus standard local zones, which are standard are mostly preferred, and unless there is a very strict requirement and you can spend a lot of money, you can go with them, and this will take some time also to set up. So use case, cost control. So these are the factors. Important service limitation, exclusive use, requires AWS engagement. There is a limited service availability. So AWS have like thousands of service, so all may not be available when you go for this particular dedicated local zones. Next, AWS Outpost. So key concepts are this is on-prem AWS infra use case, racks versus servers, and you have local gateway and hybrid connectivity. So common exam confusion points are outpost versus local zones versus wavelength. So one is location, second management and cost model. So these are the factors. Important service limitations are it requires again AWS engagement, and there is a limited service availability on the outpost. So basically, this will this is like your on-prem AWS infra use case. So you have you have your own data center, but you have to work with them to set up there is extension of AWS. So basically hybrid, and your data center and AWS cloud will work together in your own racks and servers. You can set up their whole AWS cloud. Next, AWS wavelength. Key concepts are 5G edge compute use case. So this is very specific. Ultra low latency, mobile and carrier gateway. Common exam confusion points are wavelength versus local zones and outpost. So target use case, network integration. Important service limitation, limited service availability, and it is tied to a specific telcos and mobile edge focus. Next, savings plans. Key concepts are there is a commitment model which is dollar per hour. Types that includes compute, EC2, SageMaker, and flexibility and payment. Common exam confusion points are savings plans versus reserved instances versus spot. So commitment versus reservation versus market, and how discounts apply. Important service limitations are 1 or 3 year commitment, no capacity reservation, limited flexibility to change. Compute optimizer. Key concepts are right sizing recommendations, matrix analysis through CloudWatch, and opt-in is required, and all the resources. Common exam confusion points, scope and accuracy of recommendations, interpreting the findings, and enhanced metrics. So you will you can go with enhanced metrics also, and what value they add. Important service limitations. So there's a look back period of 14 days. This is not real time optimization, and it needs sufficient data. That's why it needs 14 days at least. Like there is a waiting. Once that, then only it can do the recommendations. EC2 image builder. Key concepts are pipelines, recipes, components, automation benefits, and use cases are golden images. Common exam confusion points are recipe versus pipeline functionality, build versus test components. Important service limitations are OS support limitations, and it is not designed for instance migration. Next, service elastic load balancing. Key concepts are the types, which are application load balancer, network load balancer, gateway load balancer, and classic load balancer. Listeners, targets, target groups, health checks. Common exam confusion points are choosing the correct ELB type. So you can choose for layer 4 versus layer 7. So layer 7 is application load balancer, layer 4 is network load balancer. ELB health checks versus auto scaling group health checks. Important service limitations. Features vary by type. For example, path routing on. So path routing is available on application load balancer. And classic load balancer, there are some limitations. Amazon Light Sale. Key concepts are, these are the bundled resources. You have blueprints, simplified interface, and use cases like simple web. Common exam confusion points are, again, Light Sale versus EC2, simplicity versus control, and the cost model. Important service limitations are fixed plans, less control, flexibility, less flexibility than EC2, and limited scalability options. And that's all. Thanks for watching.